Okay, welcome. So now we're going to look at this example here, example 12. It says, consider in the vector space of the quadratic polynomials P2 the span of the set S, which is given by these two polynomials. Okay, so we've got the quadratic polynomial and we've got this linear polynomial. So if we look at the span and we want to say, okay, well, what does this look like? Well, by definition, the span of the set is the unrestricted linear combination of these two, right? So let's write this out as the span, right? So how do we do this? So the span of S is going to equal the set C1 times 3x minus x squared plus C2 times 2x such that C1 and C2 are real. Now, notice that the span of this here well, you can see that there's this how do I say this? You can see that any linear combination of this is not going to have a constant term. Right? There's not going to be a constant term in that. And the question is that okay? It's going to have a constant term of 0. It must have a constant term of 0. Okay? And is that a necessary condition or a sufficient condition? So we're asking for which members of P2 are there C1 and C2 such that we can write it as a linear combination of those two variables, right? So we're going to see when we have a combination of this, what C1 and C2, how can we determine C1 and C2? Very similar to the last problem that we did. So let's set this up. So if we have so if we set this up, we want, so C1 times 3x minus x squared plus C2 times 2x equals A0 plus A1x plus A2 x squared, right? And so we want to set up this system. And so the system that we're going to have is going to be, well, here we've got A1 and A2, right? These go with A1 and A2. This goes with A1. And so what we're going to end up having is, if we write this out, we're going to have negative C1 is equal to A2 and then we're going to have 3C1 right? 3C1 3c1 plus 2c2 is equal to A1. And then, of course, we're going to have 0 equal to A0. Right, so C1 goes with this, so A2. So if we distribute, you can see C1, so negative C1 is equal to A2. 3 times C1 plus 2 times C2 is equal to A1, and then 0, of course, is equal to A0. So this is our system that we're going to solve. And we want to see, hey, can we solve for C1 and C2? Well, yes, because if you look here, C1 is going to equal negative A2. And then, of course, C2 is going to equal what? It's going to equal A1 minus 2C2 divided by hold on. 3 minus 3 divided by 2. But C1 is equal to negative A2. Oops, hold on a second. Oh, this is C1. Didn't look right. So C1 is equal to negative A2. So that'll make this a positive, and this will be A2. And of course, A0 is equal to 0. So as long as A is A0, 0, as long as we have a constant term of 0, then we can give the coefficients C1 and C2 to describe any element of the span. So the span of the given set S So we can describe the span of the set S as follows. And also, by the way, incidentally, that set also spans the same subspace. And then of course there's this one as well, so this one also spans the same subspace. X squared negative x plus 2x squared. Okay. And there are others. So what does that mean? It means that a space can have more than one spanning set. All right, cool. Have a good day.